today we are going to graph linear inequalities and we're going to graph absolute value equations. So those are our two learning targets. So let's start off with graphing inequalities here first. So inequalities can be graphed in a similar way as linear equations and absolute value equations. So some things to remember here is that you've got that less than and greater than symbol. They don't have that little line underneath those, so that requires a dashed or dotted line. So coming over here and fill this in, this is dashed. Or some of you like to call this or dotted line. And then the equation just serves as a boundary to the area represented in the inequality. If it's a solid line, it includes the line, includes that nice solid line. If it's dashed or dotted, then that line does not, it's not included in the solution. So less than or equal to and greater than or equal to, they require a solid line. So let's go ahead and graph out this nice linear inequality here. So you want to graph out just the regular line first here. So it's in y equals mx plus b form. You can see that. So y equals mx plus b. So my y-intercept here is 1. So let's plot that out. And then our slope here is our 3. So slope equals 3 over 1. So that's rise over run. So from that point, I'm going to rise 3, 1, 2, 3, and run 1 to the right. Rise 3, 1, 2, 3, and run 1 to the right. And then I'm going to keep going the opposite direction here. So now I'm going to come down 3 and run 1 to the left. Come down 3 and run 1 to the left. So connecting those, and is it going to be dashed or is it going to be dotted? Because this symbol up here is just a less than symbol right there. That is just a less than symbol there. It is going to be a dashed or dotted line. So I like to go ahead and dash it in. Okay, so it's a nice line there. So then we have to decide how to shade this in. So since that symbol here is a less than symbol, what you want to do here is you want to kind of look at your line here. Your line here that we just dashed in here, it split the y-intercept into two portions here. You have the numbers going up this way. If you look here, you have 2, 3, 4, 5, 6, 7, 8. That's up, that's greater than. And then down this way here, you have 0, -1, -2, -3, -4. Those are less than. So this line here that we put in here, split that into two portions. So this portion up here is going up. This portion down here is going down. You want to shade in on the portion where it's smaller values, smaller y values. That's all down here on this side of the line here. These y values are all less than. So go ahead and shade on that side. So what about this next one here? Again, it's in y equals mx plus b form. So my y-intercept there is -5. So let's plot that. My slope here, you don't see it very well, but it's 1 over 1. That's my slope, so I'm going to rise 1 and run 1. And then the other direction, go left 1 and down 1, down 1 and left 1. All right, so now let's figure out which way we're going to do if it's solid or a dashed line. It's greater than or equal to, so that's a nice solid line. because that equals is underneath it, that line is underneath it. It's like they're telling you it's a solid line. All right, so then how do we shade this in? So it is a greater than. That's a greater than symbol there. So this solid line just split the graph into two portions. You've got the numbers here, -4, -3, -2, -1. Those are getting larger as we're going up. These ones on this side here are getting smaller. We want the larger values here because this is the greater than symbol. So since these values are greater than, we want this side of the line. Or some people like to think about it as being above the line, so we want to shade that in. I'll write that down, shade above the line. All right, this one here is not in y equals mx plus b form, so let's do that first. Let's put this in y equals mx plus b form. So to do so here, we're going to have to go ahead and subtract 4x from both sides. So we get y is less than or equal to -4x minus 1. So let's plot that out. So we're going to graph the line. So the first thing we do after we put in y equals mx plus b is graph the line. So my y-intercept there is -1, and my slope there is -4/1, which is my rise over my run. So I'm going to plot my y-intercept there at -1. I'm going to plot my slope, so down 4, 1, 2, 3, 4, and over 1. Can't go any farther on my graph here, so now I'm going to go in the opposite direction. So now I'm going to rise 4 and run 1 to the left. Rise 4, run 1 to the left. I'm going to connect my points. When I connect points, because the symbol here is less than or equal to, because it's equal to, it's a solid line. So connecting those points there. And doing a very nice straight one there. And then the third step here is to shade. So we have to shade, and we want to shade where it's less than. All right? So a lot of people like to think below the line, but how do you tell where below the line is? Well, this line here splits it. Remember, just kind of look at the y-axis here. The numbers down here are getting smaller. The numbers on this side are getting larger. So you don't want to shade on this side because they're getting larger. We want them smaller because this is a less than. So they're smaller on this side. So this is the side we have to shade in. So our next one here is y is greater than or equal to -1. Again, we have to graph the line, so let's do that first. So graph line. So this is y is greater than or equal to, there's not an x in here, so I'm going to do it a 0x. So the y-intercept here is -1. The slope here is 0/1, and that's our rise over run. So go ahead and plot out -1. I'm not going to rise anything, but I'm going to run 1. I'm going to keep running 1. And then I can go in the opposite direction. So you can definitely see that it is a horizontal line there. So then we have to decide if it's solid or dashed. So since this symbol here is greater than or equal to, it's got that equal there, it's going to be a solid. So we're going to connect the dots with a solid line. All right, and then the third step here, we have to shade. And we have to shade where it's greater than. So a lot of people think above the line. Where is above the line? Where the y values are getting larger. So where are the y values getting larger? Well, this is 0, 1, 2, 3, 4. Those are getting larger. These are getting smaller down here. We don't want to shade on that side. We want to shade above the line. So that means everything in this bulb portion in here. That whole thing gets shaded in. So I have two examples over here for you to do. So you can go ahead and pause the video and try those out there. And then once you get those, then resume the video, play it again, and then I'll go through those with you. All right, so let's go through these couple examples here. So this first one here, I'm going to put this in y equals mx plus b form. So I'm going to subtract x from both sides, and I get y is greater than negative x plus 6. I'm going to graph that out there. So my y-intercept there is 6. My slope here is negative 1 over 1, so I'm going to come down 1 and run 1 to the right, come down 1, run 1 to the right. And then I can go the opposite direction. So once I have that graphed out there, then my second step here is to go ahead and decide how to connect those dots. Since it's greater than symbol, it's not equal to, it's going to be dashed, or if you like to say dotted. And then my next step here is to go ahead and shade. And because it's greater than, we want to go ahead there and we want to shade above the line. Where's above the line? It's where your y values are getting larger. So they're getting larger up here. So we want to shade on this side of the line. Letter F there, let's go ahead and put that in y equals mx plus b form. So I'm going to bring everything over. I'm going to leave the y like the y on the left-hand side. So I'm going to subtract 9x, subtract 9x. I'm going to go ahead to add 6, add 6. So we get 3y is less than or equal to negative 9x plus 6. Divide everything in here by 3, and I'm not dividing by a negative, so I don't have to switch the inequality symbol. It just stays the direction it is. If that was a negative 3y, I would divide everything by negative 3, and that less than or equal to would become greater than or equal to. So y is less than or equal to negative 3x plus 2. So let's graph out that line. Our y-intercept there is 2. Our slope there is negative 3 over 1, so I'm going to come down 3 and then run 1, come down 3 and run 1. And then I can go the opposite direction. I can go up 3 and run 1 to the left and connect my points. So now I've got to connect. So connect there. I have to connect my points that's less than or equal to, so that's solid. So let's connect that with a nice solid line there. Sorry, it's a little crooked. That's a little bit better. So now I have to decide on how to shade it in. And so that's the next step is to shade. Since it's less than, we want to, I'm going to say less than, that is below. So you want to shade below the line where the y values are getting smaller. So you can see that they're getting smaller down here. These are all smaller values, so you want to shade on that side of the line, which is over here. So then on the 1-6 worksheet, you're going to do sides 1 and 2. We'll have those learning targets. So we're also going to go on to the next part here as well. So this part here is on graphing absolute value functions. So when you're graphing an absolute value function here, it's going to be V-shaped. It's going to look like a V. They're pointed. All right, so it's going to look like a V. I'm going to come down here and draw another one out. So they're all going to look like V's, whether this way or this way. So let's graph this out. So what you want to do here is you want to think about how do you get 0 inside there. You get 0 inside there when x is 0. So let's plot that out. I'm going to put that point in there, and I'm going to pick 2 points smaller than 0 and 2 points larger than 0. So if I put 0 back up in here, I get the absolute value of 0 is 0. The absolute value of -1 is 1. Absolute value of -2 is 2. Remember, whatever comes out of the absolute value is positive. Absolute value of 1 is 1. And the absolute value of 2 is 2. So we're going to plot those ordered pair. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So I'm going to connect them. It's just equal to. So it's just a nice V. There's no shading with this one. So we're just graphing out the function itself. That is just the typical one there. And, over 1 and up 1, over 2 and up 2. So if you kind of think about this one here, if inside here, inside here has a +3 in there, if you could graph this out on your graphing calculator if you wanted to as well. Let me show you how to do that in case that's going to be helpful to you. The absolute value function is underneath the math key. So I'm going to go to my y equals here. I'm going to clear out what's in there. I'm going to find the absolute value button. It's underneath the math key. I want to go over to num, and right away I see ABS. That's the ABS key. That's the absolute value. Mine shows absolute value symbols. Yours may just say ABS on the outside, and that's okay. So now we're going to put in x + 3. So you want to take the x, t, theta, n button, which is right to the right of the alpha button. I'm going to push that. The x is going to come up. I'm going to put +3, and then I'm going to hit graph. So if you think about it sitting there at 0, 0, it just moved it 3 there to the left. So if I look at my table of values there, I can start getting some values there, and I can plot them out if I want. So it's helpful if that's what you like to use. Just wanted to show you that you can graph it out using your graphing calculator as well, if that's helpful. So normally our graph here starts over here at 0, 0. So you can think about this. This is moving it left 3. You would think it's +3 there. Inside there, so from 0, 0, you would think because of the +3 that would move it to the right 3, but it's not. It's the opposite inside there, so it's left 3. So I'm going to go ahead and normally my V there is sitting there at 0, 0. I'm going to move that to the left 3. So now it's sitting over here at 3. And then from that, just always remember it's over 1 and up 1 in both directions, over 1 and up 1. From -3, 0, I'm going to go over 2 and up 2, and I'm going to go over 2 and up 2. And then I'm just going to connect my points. And it's going to look like a V. This one here, again, we can kind of think about this. We would think from 0, 0, which is right here, because that's where our normal one sits there. We call that a parent function, that y equals absolute value of x. When you graph that out, the v where it came together there, the vertex of it was sitting there at 0, 0. This one here, you would think that would move it from 0, 0. If you -3, you'd think it'd sit there at -3, 0. It's not. It's actually going to move it to the right 3, because inside is the opposite of what you would think. So let's move it to the right 3. And then again, it's just over 1 from that 1 to the right and 1 up. And then from 3, 0, I'm going to move it to the left 1 and up 1. Then from 3, 0, I'm going to move 2 over and 2 up. And then from 3, 0, I'm going to move 2 to the left and 2 up. So you can just connect it like that. Another way to kind of think about that is there's kind of like a slope there on the outside. It's 1 over 1, so you're going over 1 and up 1, or up 1 and over 1 each time, but you're going in both directions, left and right, to make a V. So now our next one here, inside here, we always move this left, right. On the outside here, we move this up or down. So on the inside here, it was a -3 there, and we moved it to the right. It was a +3, we moved it to the left. On the outside, if it's a +2, we're going to move it up 2. If it's a -2, we'd move it down 2. So in other words, always think about it sitting here at 0, 0 here to begin with. So there's nothing, we're not moving it left or right at all in this case. We're just going to move it up 2. So let's move it up 2. And then our slope here on the outside here is like a 1 over 1. So I'm going to rise 1 and run 1, but I'm going to rise 1 and then go to the right 1 and go to the left 1. So then rise 1 and run 1. Rise 1 and run 1, and then I can connect my points. And there we have our absolute value graph. So this part here, I don't want to confuse anyone here. This was y equals x minus 3, and this was y equals x, absolute value of x plus 3, which was this one. So this is the one, like I said, this is going to move it up or down. And since it is a -2, it's going to move it down 2. Inside here, this moves it left, right. And we're not moving it left, right, or at all in this case. So inside there, that's where you move it left, right. So we're just moving this one down 2. So again, starting there at 0, 0, move it up 2. So we're just going to go up 2 from that. And then we're going to go up 1 and over 1, up 1 and over 1. And then from our new points that we just did on both sides here, so the one sitting there at 1, 3 and the one sitting there at -3, 1, we're going to move up 1 and over 1, up 1 and over 1. So it looks like a V. And connect our points. So now what happens if you've got a negative on the outside? Well, the negative there on the outside is going to make it upside down. So it's going to look like this. It's just a reflection. So normally it's sitting here at 0, 0, and then we're going over 1 and up 1, and it's going to look like that, right? Well, in our case here, this is like it's a -1 over 1. So we can just go over 1 and down 1, 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 and connect our points. So it's like it's being reflected over the x-axis, or some people think the slope just switched on us. Either way, you can do it either way. That one we already did, so I don't want to do that one again. Let's go to letter H there. We've got this -1 over 1, and then we've got this x minus 3 on the inside, and on the outside we have a +4. So remember, on the inside here, this is left or right. In our case there, you would think that it should move it to the left because it's a minus, but nope, it's going to be right 3. And you would think on the outside here, this is the up or down, and you'd think this would be up 4, and it is. It is up 4. So let's do that. From 0, 0, we're going to move to the right 3, and we're going to move up 4. So I moved to the right 3, and I moved up 4. And then from that, I have that negative 1 over 1. So I'm going to come down 1 and over 1. Down 1, over 1 in both left and right direction. Come down 1, move 1 to the right. Come down 1, move 1 to the left. And then connect my points. And I could keep going with that. I just stopped after 2 points. Or actually, we did 5 points. Let's do another combination here. This one here, again on the outside this acts as a slope, and on the inside here, that x minus 1 here, that's left or right. And it's going to move it 1. So which way are we going to move it? We're going to move it right 1 because it's minus. And then here on the outside there, we're going to either move it up or down 3. Since it's a minus there, we're going to move it down 3. So we do that first, right 1 and then down 3. So make sure you do both. And then the slope there is 2 over 1. So we're going to go up 2 and over 1. Up 2 and over 1. Come back to the vertex, go up 2 and left 1. Go up 2 and left 1. Connect your points. And we could keep going with that. So now you can go ahead and do the other sides of the 1-6 worksheet, sides 3 and 4.